Hello and welcome to our video. In this video, we will introduce you to suspension rubber bushings. First, we will have a quick introduction to them. Then, we will break down a cylindrical rubber bushing by its components, as it is necessary to outline the basics of rubber material characteristics to understand the function of a rubber bushing. We will cover a few definitions. Then we will outline the deformation modes of a rubber bushing and demonstrate each mode with animation. Finally, we will assemble a rubber bushing into a truck suspension system to demonstrate its application and functionality in a real example. If you enjoyed this video, please don't forget to hit the like and subscribe buttons to our channel for more upcoming videos. The suspension rubber bushing is an essential part of a vehicle suspension system. They prevent erosion due to metal contact between the distinctive parts of the suspension structure. Also, suspension rubber bushings play an important role in the noise and vibration control of a vehicle. They isolate the vehicle body from the vibration source, such as unbalanced wheel and tire, road input, and powertrain. Also, they limit the amount of movement from road inputs, hence improve the driving experience significantly. Now let's take a look at the components of the suspension cylindrical rubber bushing. They consist of three main parts: the outer layer of rigid metal, also called the sleeve, then we have the rubber tube, made from a natural rubber mixture, and the torque rod made from steel. The rubber tube is bonded to the inner and outer surfaces of the sleeve and torque rod, respectively. The bonding happens during the bushing production by using transfer and injection molding presses to bond the natural rubber mix into the metal components to make the final product. To better understand how rubber bushing functions in a suspension system, we first need to have a basic understanding of the main characteristic of a rubber material. One of the important characteristics of rubbers is their ability to recover their original shape after being deformed due to their flexibility and elasticity. Thus, they have a reliable capacity for dissipating dynamic and vibration energy. This behavior of rubber can be represented by the hysteresis loop, enclosed by the loading and unloading curves in a stress-strain diagram. The area between load and unload curves represents the energy dissipated mainly as heat. For free vibrations, this phenomenon is termed the damping capacity. This is an important parameter as it determines how much dampening can a bushing provide for a suspension system. We will cover more details about rubber properties in a separate video. Next, we will cover the deformation modes of the rubber bushing. In general, cylindrical rubber bushings have 6 degrees of freedom or deformation modes. This means they can move in 3 translational directions, which are radial, normal, and axial, and in 3 rotational directions, which are torsional and 2 conical. Each deformation mode will be animated here. Also, please note to better observe the deformation modes of the rubber bushing. Here we are showing the relative motions of the torque rod to the sleeve. However, in most applications, the sleeve moves relative to the torque rod. This will be shown in the suspension system at the end of this video. One important point about cylindrical rubber bushings is that they transmit significant loads mainly in their 2 principal, radial and axial, directions. In the radial direction, bushings demonstrate high, nonlinear stiffness owing to combined shear, compression, and extension of rubber. In the axial direction, bushings show lower, linear stiffness, as in this case only shear deformation is present. In all 3 rotational deformation modes, torsional and conical, bushings are much more compliant as the rubber is less under stress than the axial and radial deformation modes. In these modes, the bushing acts primarily as a kinematic joint, hence, transmitting a smaller amount of loads. To demonstrate the application and function of the cylindrical rubber bushing in an actual suspension system, we will be assembling the main parts of a leaf spring suspension. Leaf springs are typically used in the rear suspension of heavy load-carrying vehicles such as trucks. As you can see, the bushing is press-fitted into the eye of the leaf spring. Then the leaf spring is bolted to the frame hanger by the torque rod of the bushing. The proper bushing size should be selected considering the maximum bending stress on the leaf spring and corresponding vehicle payloads that will have an impact on the leaf spring. All these calculations are performed during the engineering design process of the suspension system. The hanger is connected to the rail frame, which is a part of the chassis of the truck, with bolts. Now, we will demonstrate to you how the rubber bushing will enable the leaf spring to move relative to the chassis assembly in all the 6 degrees of freedom or deformation modes we covered earlier. In the first motion, the leaf spring is rotating along the axis of the bushing. This was shown in the motions of the bushing as the torsional deformation mode. In the next leaf spring motion demonstration, it can be seen the leaf spring is moving in the translational direction, or side to side. The axial deformation mode of the bushing will enable the leaf spring to have such motions. This motion on the suspension will happen due to lateral loads to the tire. We will be covering all the suspension loads in a separate video. Now you can see the leaf spring is twisting. The conical degree of freedom of the bushing enables the spring to perform such motions. The twisting of a leaf spring can happen due to the chassis twisting across articulation loads imposed on the axle of the suspension. The normal deformation mode of the bushing enables the spring to move fore and aft during the braking and acceleration of a vehicle. Lastly, the radial deformation mode of the bushing well connected to the leaf spring is demonstrated. This deformation mode occurs during vertical load to the axle of the vehicle. Lastly, let's cover the advantage and disadvantages of rubber bushings. Advantages of using rubber bushings are: they are relatively cheap, provide improved safety and comfort when driving, they minimize noise and damage caused by vibration. Shock rubber bushing can provide a long, maintenance-free service life. Disadvantages of using rubber bushings are: they can wear down over long periods of time. They are difficult to replace. We hope you enjoyed this video. Please stay tuned for more videos by subscribing to our channel. Goodbye.